Number 16. So, ang una natin gagawin is isusulat natin yung mga given. So, yung una natin given is yung 1 kilowatt or equivalent siya sa 1 times 10 raised to 3 watts. So, yung pangalawa natin given is yung voltage, which is equal to 230 volts. Yung pangatlo naman natin given is yung diameter, which is equal to 0.5 millimeter, or ko-convert na natin siya sa centimeter. Since yung resistivity natin is in terms of centimeter. So, i-multiply natin siya sa 1 centimeter over 10 millimeter. Makakancel yung millimeter at yung matitira na lang is yung centimeter. So, bali, ang diameter na natin is 0.05 centimeter. At yung last na given natin is yung resistivity, which is equal to 60 times 10 raised to negative 6 ohms centimeter. At yung pangalawa naman natin gagawin is i-determine natin kung ano yung unknown, which is sabi dito sa question, calculate the necessary length of the wire. So, ang unknown is yung length. So, ngayon, magde-derive tayo ng formula. Since given ang resistivity at diameter at ang hinahanap natin ay ang length, pwede natin gamitin yung resistance equal to resistivity multiplied by length all over cross-sectional area para makuha yung formula ng length. So, ito na ngayon yung formula ng length. Length is equal to resistance multiplied by cross-sectional area all over resistivity. Pero hindi pa yan ang gagamitin nating formula. Dahil wala din yung resistance at ang cross-sectional area. Kailangan pa nating hanapin yung formula para dyan. So, ang resistance ay unknown. So, gagamit tayo ng formula. Gamit ang voltage is equal to current multiplied by resistance at ang power which is equal to current multiplied by voltage, makakapag-derive tayo na ang resistance ay equal siya sa V squared all over power or yung volts squared all over power. So, ito na ngayon yung R natin. Papalitan na lang natin yung R natin ng V squared all over P since given naman na siya kanina, which is yung P, 1 times 10 raised to 3 watts and voltage, 230 volts. So, yung cross-sectional area naman natin, ang formula na gagamitin natin is pi d squared all over 4. So, eto na ngayon yung formula or yung final formula na pwede nating gamitin. So, length is equal to v squared all over p multiplied by pi d squared all over 4 all over by the resistivity. So, eto na ngayon. Magsasubstitute na tayo ng values. So, sa V natin, 230, i-square natin siya all over yung P, yung power, which is 1 times 10 raised to 3 watts. So, multiplied by pi, yung D natin is 0.05 cm, so i-square din natin siya all over 4. So, i-over lahat to sa resistivity, which is yung resistivity natin is 60 times 10 raised to negative 6 ohms centimeter. So, after nyan, makukuha nating sagot ay 1,731.15 cm. So, ito na yung final answer. So, dito, makakancel tong centimeter na to. At yung ito magiging ohm, so makakancel din siya. So, ang matitira lang dyan is yung 1 centimeter. Kaya, 1,731.17 cm. Yan yung length ng wire. Number 17. So, may dalawa tayong type ng wire. Yun yung aluminum wire at copper wire. So, para magkaroon ng distinction sa pagsulat natin ng given, linagyan natin siya ng subscript. Para sa aluminum wire, ang subscript niya is AL at para naman sa copper is CU. So, ang given sa problem na ito is yung length ng aluminum wire, which is 5 meter or 5 times 10 raised to 3 millimeter. Tapos, yung diameter ng aluminum wire, which is yung 2 mm. Given din yung current ng aluminum wire, which is 2.5 ampere. And yung resistivity niya, which is equal to 2.6 times 10 raised to negative 3 ohms millimeter. Para naman sa copper natin, ang given para sa copper wire is 3 meters yung length niya, or 3 times 10 raised to 3 millimeter. At yung resistivity niya, which is 1.7 microohms centimeter, or 1.7 times 10 raised to negative 3 ohms millimeter. So, kinonvert natin siya sa millimeter para maging consistent yung unit na gagamitin natin. So, at yung last na given is yung I total, which is 4 ampere. So, pagkatapos natin sa given, sulat naman natin kung ano ang hinahanap yun sa problem. Yun is yung diameter ng copper. So, para naman sa formula, kung makikita nyo, given ang diameter, yung length, at yung resistivity. So, pwede natin gamitin ito. Itong resistance is equal to resistivity multiplied by length all over cross-sectional area. So, una natin kunin is yung resistance since walang given na resistance. So, para makuha natin resistance, gagamitin natin formula is V over I, or voltage over current. At na-derive natin itong formula na to gamit ang original formula na V is equal to IR. So, dito naman, gagamitin natin siya sa dalawa, sa aluminum wire at sa copper wire. So, ganito na ngayon ang formula. R, or resistance ng aluminum all over resistance ng copper, is equal to resistivity ng aluminum multiplied by the length of aluminum wire all over its cross-sectional area. Ganon din yung sa copper. Yung resistivity ng copper multiplied by the length of the copper all over cross-sectional area ng copper. So, papalitan natin ngayon yung resistance, yung R ng V all over I. So, V over I, current ng AL all over voltage all over current ng copper is equal to yung copy lang natin to. Kinapi lang natin to. So, ito lang din yon. So, dito, pwede natin cancel yung voltage. So, ang matitira na lang is yung current ng copper all over current ng aluminum. So, copy lang ulit natin ito. So, dito na tayo sa solution. I-input na tayo ng mga values gamit ang mga given. So, dito, kukunin muna natin pala yung current ng copper since hindi given. Need natin siya sa need ang value ng current ng copper dito. So, para makuha yung value ng current ng copper is, kailangan natin yung I total is equal to current ng aluminum plus I copper, or aluminum current ng copper. Yung I total natin is 4 is equal to 2.5 plus I copper. So, ang current ng copper is 1.5 ampere. So, yung cross-section naman ng copper ay pi d squared all over 4. So, papalitan lang natin yung A mamaya gamit ito. At dito naman sa cross-sectional area ng aluminum, kokopyahin lang natin yung formula, papalitan natin yung D ng 2. So, ito yon. So, cancel yan. So, ang magiging cross-sectional ng copper ay pi lang. So, isa-substitute natin yung mga values dito sa formula. So, 1.5 ampere all over 2.5 ampere is equal to yung resistivity ng aluminum, 2.6 times 10 raised to negative 3, multiplied by the length of the aluminum wire, 5 times 10 raised to 3 all over yung cross-sectional ng aluminum wire, which is yung pi. Tapos, dun naman sa copper, yung resistivity niya is 1.7 multiplied by 10 raised to negative 3, multiplied by 3, yung length niya, 3 times 10 raised to 3 all over pi d squared all over 4, or, yun na yun. So, pagkatapos yan, pwede natin i-calculate, at ilalabas sa calculator natin is, this equal to 0.970329 millimeter. So, pwede natin itong i-caltech. Shift solve natin. So, dito sa number 18 and 19, pinag-combine na lang natin siya since iisa lang naman yung problem na may dalawang unknown. So, una natin ginawa is sinulat natin yung given, which is yung mauuna yung voltage, which is equal to 230 volts, yung power, which is equal to 150 watts, and yung T1 natin, which is 2,750 degrees Celsius, at yung T2 natin, which is equal to 16 degrees Celsius. At yung last na given natin is yung temperature coefficient ng tungsten, which is equal to 0.0047 per degree Celsius. So, pagkatapos natin isulat ng given, isulat naman natin ngayon yung unknown. So, bali sa number 18, yung unknown is yung current or normal current taken by the lamp. Tapos sa number 19 naman is yung the current taken at the moment of switching on. Nung inon daw, ano daw yung current na after switching on. So, dito naman, yung formula na gagamitin natin para sa number 18 is power is equal to current multiplied by voltage. So, gamit ang formula natin na ito, makakapag-derive tayo ng formula na kung saan makukuha natin yung current. So, current is equal to P all over voltage, or power all over voltage. So, yan na yung formula natin sa number 18. So, para naman sa number 19, ang formula na gagamitin natin is yung temperature coefficient of tungsten, or temperature coefficient is equal to 1 over temperature initial. So, sa pamagitan nito, makukuha natin yung temperature initial, which is equal to 1 over the temperature coefficient. So, ito yon, formula na gagamitin natin mamaya. So, pagkatapos nun, makuha natin yung temperature initial. Magagamitin naman natin ngayon yung R1 all over R2 is equal to temperature initial plus T1 over temperature initial plus T2. So, dito, since hindi given ang R1 natin, magdederive ulit tayo ng formula gamit ang V is equal to I R, or current multiplied by resistance. So, ang resistance natin is equal to voltage all over the current. So, gamit ang formula na to, papalitan natin yung nandito. So, ito na ngayon, V1 all over I1. So, pwede natin palitan to, V2 all over I2 is equal to TO plus T1 all over TO plus T2. So, dito sa solution natin, so, una nating bibigyan ng solution is number 18. So, ito ang gagamitin nating formula. Current is equal to power all over voltage. So, ang power natin is 150 watts at yung voltage natin is 230 volts. So, input lang natin sa calculator at makukuha natin to. Current is equal to 0.6522 ampere. So, para naman sa 19, so, para makuha natin yung temperature initial, so, ito ang gagamitin natin. 1 all over 0.0047 per degree Celsius. So, magiging temperature initial natin is 212.77 degree Celsius. So, i-input lang natin tong mga value na to dun sa formula na ito. So, 230 volts all over 0. Yung I1 natin. So, ito yung I1 natin. 0.6522 all over 230 volts over I2, which is yung unknown, is equal to temperature initial, which is 212.77, plus yung T1 natin, which is 2750 degrees Celsius, all over 212.77 degrees Celsius, plus yung T2 natin, which is yung 16 degrees Celsius. So, pag sinolve natin yan, gagamitin natin yung calculator natin, makukuha natin yung yung current natin, pagkatapos i-on, yung gas is equal to, gas lamp is equal to 8.4466 ampere. So, yun yung solution na number 18 and 19. number 20. So, una natin gagawin dito is isulatin natin yung given. So, yung resistance 1 natin is 120 ohms. Yung temperature 1 natin given din, which is equal to 25 degrees Celsius. Yung resistance 2 o yung resistance na after nung pag-increase ng temperature is 140 ohms at yung temperature coefficient is equal to 0.0042 per degree Celsius. So, yung unknown natin dito is yung change in temperature. So, ang gagamitin nating formula is yung formula ng temperature coefficient which is equal to 1 over TO. Para makapag-derive tayo ng formula na kung saan kukunin natin itong initial temperature. So, initial temperature now is equal to 1 over temperature coefficient. So, isa pang gagamitin natin formula is yung R1 over R2 is equal to initial temperature plus T1 all over initial temperature plus T2. And yung last is yung change in temperature is equal to T2 minus T1. So, dito sa initial temperature, 1 all over 0.0042 per degree Celsius. So, ang TO natin is yung 238.0952 degrees Celsius. So, i-input natin siya dito sa formula na to. Yung R1 natin, gagamitin natin, 120 ohms. Yung R2, which is 140 ohms, is equal to yung TO, 238.0952 plus T1. Yung T1 natin is 25 degrees Celsius all over 238.0952 plus yung T2, which is yung unknown. So, T2 na ngayon is equal to 68.8492 degree Celsius. So, para makuha natin yung change in temperature, kailangan natin isubtract yung 68.8492 minus 25, which is equal to 43.85 degrees Celsius. So, ito na ngayon yung sagot.